Okay, in this section, we're going to talk about something called the composition of functions. And at this level, it may not seem that pressing to understand the ins and outs of it, but as you advance through mathematics and physics and chemistry, you're going to start seeing these functions composed many, many times. You're going to start being able to break them down. So when you see one function that's composed of more than one other function, you can break it down into two independent functions. But at this level, we're going to be going through and applying the definition of the composition to our independent functions. So let's just go out and start with an informal definition. So an informal definition. So we'll say the composition, so we'll say let f of x and g of x be independent functions. The composition of f and g is f open circle g. So that's not a times. It is not a multiplication symbol. It's open circle, and it's in the middle. It's floating in the middle. So we say f composed of g of x is equal to f of g of x. And then they have a little domain. So I'll put a little domain portion here, a little extra that talks about how to determine the domain. And then it says where x is in the domain of g. So x is in the domain of g, and that makes sense. And g of x, this whole thing, g of x will be, okay, take a stab at it, will be in the domain of f. So for right now, it's not that important for us to understand the domain part. I'm going to do a second video on recognizing the domains, but right now we want to make sure that we can apply the definition of the composition of two independent functions. So let's go ahead and try an example out and see how we do. So we're going to say that given f of x equals to 3x plus 5 and g of x equals to x squared plus 2x plus 1. So in part A, we're going to determine f composed of g of x. And then in part B, we're going to determine g composed of f of x. So here we're going to have f composed of g of x and then g composed of f of x. So by definition, I'm going to make this a little bit easier maybe, and I'm going to write this in color. So I'm going to say that f of x is equal to 3x plus 5, and then in blue I'm going to rewrite g of x, which will be in terms of x squared plus 2x plus 1. Because I like to use a lot of colors. I think it makes it a little bit easier to understand. So by definition, we're going to have f of g of x in this circumstance. So we're going to apply the composition. So we're going to have f of g of x. So everywhere in f we see an x, we're going to plug in g of x. So we're going to have f of g of x, but g of x is equal to all that stuff. So it's going to be x squared plus 2x plus 1. And we plug this in, so we're going to have 3 times x squared plus 2x plus 1. And we're going to add 5 at the end. So we just plugged it in everywhere we saw an x. And this will give us 3x squared. And we have to distribute this 3 to all 3 terms. So plus 6x plus 3, still plus 5 at the end. And that's going to give us 3x squared plus 6x plus 8. And that will be our composition of f composed of g, Fogg. And a lot of times you might hear the term Fogg and Goff. Fogg and Goff apply to this formal practice of how to determine the composition of two functions. So now if we want to find Goff, or g composed of f, this will be g of f of x, but I'm going to write f of x in red so we can see it. So we're going to have g of f of x. So everywhere in g we see an x, we're going to have to plug in f of x. But f of x will be equal to 3x plus 5. So we're going to have 3x plus 5 squared, because we're plugging it in here. Then we're going to have plus 2 times 3x plus 5. And then at the very end, we're going to have a plus 1. So in this circumstance, we're going to have to FOIL out that 3x plus 5. Don't make the mistake of trying to distribute that square. You can't distribute a square. You can't distribute a square to these two terms. So that would be incorrect. Once you have this square here, you have to expand and FOIL it out twice. So be careful about that. I'm going to distribute this 2, however, in my second set of parentheses. So I'm going to have plus 6x plus 10, still plus 1 at the end. And now we're going to FOIL out these binomials. So we're going to have 3x times 3x gives me a value of 9x squared. 3x times 5 gives me a value of 15x. 5 times 3x gives me another value of 15x. 5 times 5 gives me a value of 25. And then I still have all of this stuff at the end. So now I'm going to combine similar terms. So I'm going to have my 9x squared, so that's going to be gone. So I got the 9x squared. 15x plus 15x gives me 30x. Plus 6x gives me plus 36x. So I have plus 36x. And then lastly, I'm going to have 25. 10 makes me 35, plus 1 gives me 36. And now I've combined all my similar terms, and I have a value of 36 at the end. So this is how we're going to apply the definition of the composition of two or more functions.